Right, so this is all about towards GQL version 1, about which you've heard a bit about already in the preceding two talks. So I'm Petra Selmer. I'm part of the Query Languages Standards and Research Group at Neo4j. And a large portion of the work we actually undertake, excuse me, my team and I, is to actually essentially fill out the GQL draft standard. Right, so the topics I'll be covering in the talk today is what is GQL, how is GQL produced, and also what does GQL look like. So just one thing to actually bear in mind is GQL is still very much under development and it's far from final. So features may actually be changed, dropped, or moved to a future version. And in fact, we've seen a lot of that happening as of recently, which is what Keith alluded to as well. Something else that's actually worth mentioning is the notion of featureization. And in fact, this is what we're going to be doing in lockstep with SQL PGQ, is that essentially any implementation that is going to be stated to be conformant to GQL must implement a minimal subset of features, which means there are loads of features that are actually optional. So that's actually quite a good way to get onto the first rung of the ladder of GQL implementation. Lastly, just to mention is that nothing I'll be saying in this talk actually represents a commitment by Neo4j to implement GQL or any of the features. Right, so what is GQL? So as you probably know by now from the first couple of talks, it's basically the standardization effort for a brand new graph query language. So very importantly as well is it does not sit on top of SQL, it actually sits alongside SQL. So, and this basically was brought about, as you probably all know, by growing adoption of property graphs in the market. And essentially that's definitely so far from all the statistics we've been gathering is the fastest growing database segment at this moment in time. And also this actually all came to pass through Alistair's GQL manifesto. And since he's in the room, I'm sure if you want to know more about that, just chat to him. But essentially, this is what kicked off the whole process. Also in the diagram on the right-hand side shows a few of the input languages that actually have been fed through into making GQL what it is today. And to that image, this is a more detailed diagram just showing the lineage. So essentially which languages influenced which other languages and also which languages imparted various features which will now be taken into GQL. So hopefully I've got everything right in this diagram. If there's something that actually somebody has spotted that is missing or incorrect, I'd be very interested to know what that is so I can actually update that. But anyway, I'll leave this for you guys to look at offline. So yes, this deals with the property graph data model. So what's actually quite important to actually draw out is that both nodes and edges can have 0 or more labels. So the various vendors actually implement various subsets of this. So for example, in Neo4j, an edge will only have one and only one label. However, the GQL graph data model actually is a superset. So we'll be allowing for vendors to implement a 0 or more labels for an edge, for example. Same goes for nodes, and of course, 0 or more properties as well. Something else that's actually worth pointing out is that the data model also allows for directed and undirected edges in the model. And in fact, a model may have both types of edges as well. And in fact, when we get to the ASCII art section, although I don't have any examples of that here, we actually do now have different syntax showing how you can actually match an edge that's pointing left, but that also may be undirected. So a whole lot of new things in the bag. Right, so, oh yes, and also the fact that graphs can have labels and properties. I have a feeling though that may actually now be one of the things that actually drops off. And that's simply, as I'll be talking about later on, we actually are trying to get things done. Right, so this is all predicated very importantly on a very, very important principle, and that's visual graph pattern syntax. So I think everybody by now is very familiar with the match pattern syntax. And just to actually note, we were definitely not the first people to come across this. So way back in 76, this sort of thing was already bursting out, essentially. So moving on. So a few goals that we actually try to keep in mind when setting up GQL, and also that we try and keep in mind as we actually are processing further on with that, is that essentially it's an effort that we actually are very, very excited to have both research and industry being involved. It's also something that we are aiming to actually have as a universal property graph query languages. So that basically means that, like SQL, we hope that in due course, GQL will become one of those skill sets, for example, that developers will really feel motivated to actually invest in, and that thing I can put on their CV and so on and so forth, all those good things. We also want to make sure that the graphs, the notion of graphs is established as a primary data model, and also making sure that we are also backwards compatible with existing languages. So what we've actually done in working with SQL, in particular with SQL PGQ, is to make sure that we don't actually idly vary from SQL. So if SQL does something in one way and we notice that in GQL we're going to do that same thing, we're actually going to attempt to stick with the way SQL does that. And again, that's just to make sure that we basically keep in lockstep. We don't actually vary for no particularly good reason. Yeah, and also what we want to try and do with standards, it's a great thing, is to actually essentially grow the property graph space, right? So basically increase market share insofar as that data model is concerned. A nice outgrowth as well is actually that we are hopefully going to be able to integrate into other modern technology standards. I've listed a few over there. And very importantly, we want to actually aim for a standard that's easy to learn, use, teach, implement, and most importantly as well, evolve. Right, so I think actually Keith had a very similar slide up, so I'll just go through this very quickly. So GQL, being a standalone language, sitting on its own merit, essentially will allow for three things: graph pattern matching queries, also the ability to actually update, delete, and create graphs, and of course, DDL, allowing you to actually manage your graphs, catalog, schema, etc. An important thing to mention around the idea of schema is that actually we'll be supporting in the first version 2 modalities. So your graph may either be have no schema, or it actually will have a full schema. So we're not yet catering for a partial schema. That is hopefully something we'll get to in a future version. But for now, it's either one or the other for any one particular graph. Right, so here's a bit of information about how GQL is actually produced. So again, I'll actually skip over the slide. Keith spoke about that. So just to drive home again very clearly that the pattern matching element of SQL PGQ and GQL is absolutely identical. So obviously things are a bit different at the beginning and at the end. So where the actual results from a pattern match escape, if you like, that looks different for SQL PGQ and for GQL. But otherwise, the actual match pattern statements are all identical. Excuse me. So just to again point out, I think there's a variation of the slide already, is the community is much wider. So it's not just obviously the ISO IEC JTC1 sort of group, but we also have a liaison with the LDBC, which has actually proved very fruitful. So we actually have a talk later on, and also we have other groups ongoing as well. So as Leonard mentioned, the outputs by the formal semantics working group certainly did actually prove very useful in certain contexts, and have actually made it into the standard. So that sort of contribution really does make a difference. So hopefully that will continue. So you may be actually wondering how the journey looks. So, say there's actually a paper to propose a feature. How does that actually eventually make it into the draft standard? So I'll sort of take you through what we actually see from our end. So essentially what actually happens is that a paper is produced, and very often it will be something called a change proposal. And that will consist of 2 sections. It will actually consist of a discussion section where you are just talking about the particular feature and provide examples and motivations, etc. So it's very, as the name suggests, a discursive explanatory piece of text. That will then be followed by the change proposal itself. And that's done to a very sort of strict format. So hopefully you can see in the image on the left-hand side, there's like a dark blue striked out text that actually shows text that currently exists in the draft, but that should be removed because the feature you're proposing means that that text is no longer valid. Any new text that you add is then in this bold red that you can see over there. And usually that's actually what makes these papers rather long. So, so papers produced, and then it's actually submitted to the GQL expert group, which is something Keith mentioned. And as he also mentioned, we meet once a fortnight. And what actually happens there is that paper is then presented. So that's a part of the US National Standards Body. And of course, during the course of this 2-hour meeting, paper gets presented, there are loads of questions, loads of discussions. Sometimes there are actually objections. Sometimes there are requests to change something. So sometimes there'll also be a revision to that paper, which is what we then do as well. That revision then gets submitted. And then once everybody's happy with that, we essentially decide as a group whether or not to submit to WG3. And assuming the paper is actually agreed upon by everybody, and it gets shunted off to WG3. It will then actually get presented at the WG3 version, usually in a much more truncated form. And at that point in time, it's sort of a rubber stamp, yes, it goes into the draft or not. If there's an agreement to actually essentially accept the proposal, it then actually gets added to the draft. And this is actually where Stefan and Stephen, our editors of GQL, actually take a lot of time to actually take that change proposal and to very, very carefully incorporate it into the standard. And that's usually takes a couple of weeks. So it's certainly not a trivial piece of work. And just a bit of information on the GQL standard as it stands at the moment. It's 505 pages. We usually get a new release every month, and this is actually because we have a WG3 meeting once a month. So it does get updated quite frequently. What's pretty much already in and looking, in all stages from actually complete through to kind of almost on the finish line is pattern matching. And of course, this is because we had to maintain parity with SQL PGQ. Also the execution model of the standard, environment and catalog, data model and basic graph schema, and predefined data types, mostly also offering what SQL does. However, we're actually still working on query structure, DML, the type system. That's actually a massive piece of work, resolving all sorts of issues and comments, and also very importantly, reducing the size and scope. So you actually may be wondering why it is that we're removing things. So back when we started, what we actually did was we tried to get the bigger picture of GQL. It's actually Stefan in particular went through a lot of trouble to actually make sure that it's like the whole picture was drawn out, or at least the borders of what GQL could look like was reflected in the standard. And as we've actually worked on that, we've actually realized that some bits actually would probably benefit by being considered later on. So we actually have identified a minimal subset, if you like, and it's actually much more worth getting that solidified and correct and as possible. Another thing to actually bear in mind is we want the standard to be a living document, and that is to say we definitely want every property graph vendor now, but also every property graph vendor in the future to adopt GQL. And the best way to actually do that is to make sure that they've got as small a standard as possible to implement. Because I don't think there's anything worse than giving them a 2,000-page document with where 90% of the features are mandatory. Nobody's ever going to be able to get onto the first rung of that ladder. So we just want to make sure that we produce something that's workable for a first version, and that every new developer on the block can actually start to implement. It would also be very good, we've been finding, to actually see what our users think. So once we've actually implemented feature X, say, in any product, it could be that actually users could determine the direction of what actually happens in version 2. They may find certain things more useful than we have thought. So we also want to have the opportunity to see what actually comes out of that. So essentially the idea is to start small and to basically layer on incrementally over the next few versions, basically adding on new features. So what does GQL actually look like? So first of all, it's going to support querying multiple graphs. So as you can see in this particular example over here, we actually have a graph called Twitter. And again, this actually shows the catalog. So assume that there's a Twitter graph stored in the SOCNet namespace in your catalog. So from this graph over here, you do some matches, and then you actually union that with another graph called Instagram, which actually happens to sit in the exact same namespace within your catalog. So you actually are able to draw results out of both of these graphs, and then you actually come out of there, you've got the result set, which contains all of your matches from this query inside, and then you can actually carry on matching, right? So as you can see over there. So that's one of the big features that's conferred by GQL. Leonard also already went through this at length, so I'll just basically focus on the things that maybe are worth mentioning. Is what's very different is that in the graph pattern matching, we're actually also going to have label expressions. So for nodes and for relationships or edges, you're actually going to have the ability to actually formulate complex label expressions. So instead of just saying no's or no's and likes or something like that, you can actually formulate using parentheses much more complex expressions. So you can, for example, say person and employee and not something else. So you essentially can really layer on very expressive label expressions. As we've already seen, path pattern union. So that's a set union, this first one here. Hopefully my mouse is coming through. If you actually don't want to have the deduplication operation occurring, you just then use something called multi-set alternation, which is then pipe plus pipe instead. Quantified path patterns, so Leonard talked about this a lot. All I'll mention is that it's very important to realize that you can actually compose all of these operations. So say take quantification, you can actually have multiple quantifications in any path pattern. So for example, you can actually start off a path pattern with some fixed portion, say A going to B. Then you can actually have a quantified part in there. Then you can drop out of that and then go into another fixed portion. And then you can actually have another quantified portion. So you can actually express really, really sophisticated path patterns where bits of it essentially are flexed through quantification. Another thing to bear in mind is that with union and with alternation, quantification can also appear in there. So I've actually illustrated that in this query over here. So an entire union can actually itself be quantified. And it's also important to note that that an operand to one of these unions as well can in and of itself be quantified. What will not be appearing, although we did actually explore that within SQL PGQ in particular, was nesting of quantifications. So that is something we looked at. We actually made sure that if we ever did want to open that box, it is possible to do so. So the semantics we've defined now don't prohibit that, but we've actually drawn back from that. It's very complicated to specify. It's probably going to be very complicated for users to write, and probably they won't actually even understand where to even begin. So it's like, let's not go there for now, but that I thought was just worth mentioning. And then of course, matching walks, trails, etc. But Leonard mentioned that as well. So I'll just move on from there. And the other thing actually is a graph schema idea. So Neo4j in particular, in the first version of Cypher, started off with there being no schema. And we have found this, speaking as Neo4j, a very useful thing to have, so people could just explore with their data model and basically not have to worry about defining a schema up front. That's super useful up to a point, because at the point at which you actually have your data model in place, you want to start adding constraints and making sure that your data is tidy, that it actually is compliant in some way, shape, or form. You want to ensure data quality. So in which case, the notion of a graph schema is incredibly useful. So what we actually have is a construct called graph type, and this essentially is how you can define a schema of your graph. This again just shows you the intuition around that. Once again, in keeping with the sort of a minimal viable walking skeleton, if you like, is we are only defining these sorts of structures for now. Not yet defined are all these other good things over here. And a lot of this has actually come out of the property graph schema working group. And that again is really, really good stuff, but it'll be for later on. This again just shows the graph type in a bit more detail. So again, it's just showing very particularly what actually is going on here. So you can actually create a graph type called social network, and then you've got these various node types and various relationship types. So you can actually see what's basically on offer here. Right, and then of course, last but not least, DML. So pretty much as you'd expect, so that's all in place. And conversations have actually been going on last week in Berlin around this. And oh yes, I should also mention, we're also looking at not just having match, et cetera, return, but also having a select variant. So for those vendors who wish to stick with select as their projection mechanism, that's also in play. And this is basically what it looks like. And that's about it for me. So I guess just to reiterate, yes, it's a lot of work. We have still a long way to go. But yeah, we're getting there slowly but surely. Thank you.
Thanks very much, Petra. I have a question right away. So updates seem to be a distinguishing feature of GQL. Are there any plans to take this to SQL PGQ, or is it always going to stay like this, where that is read-only?
I think that's probably a question for some of the PGQ folks I see are on this call, but it's certainly something we always had agreed upon as being one of the defining features of GQL was DML was going to be there as a first-class citizen, if you like, but I cannot speak for SQL PGQ, so maybe somebody else can take that.
Okay.
From what I, hi Oscar here.
Hi.
From what I understand, I mean, there's basically no plans, definitely not for the first version. But we're not saying like we will never add it to a SQL PTQ, but not in the first version. And we don't really have worked on it. Yeah.
Okay, so it doesn't seem very likely. Okay, other questions? Looking around in the room.
So what about node construction, Petra? What is the status there?
So I didn't quite catch that. What about something construction?
Constructing new nodes and edges.
So you can do that to an existing graph. You can actually add new nodes and new edges with no problem. So you can add new nodes, new edges. You can change labels of existing nodes and edges, and obviously change properties of existing nodes and edges.
Yeah, but okay, thanks. But the return mechanism, so the select mechanism would be returning a table, and otherwise, I mean, but is it possible to return a graph? That was also an important.
It is important, but it's actually something that actually for now is off the table for version 1.
Okay, so select is the only mechanism to return.
No, both select and return are in, but return will only be returning a table for version 1. To only be returning the results in a tabular form.
Are both returning a table, in fact.
Correct.
Okay.
Syntactic sugar and salt.
Yeah. Okay. Well, that is a bit of a loss, I think. Yeah. But okay. Okay. Well, let's hope for the second version then.
So much for version 1.
Online questions. We have one from Ebran. Go ahead.
Yeah, you mentioned the schemas. Is there any plans for inheritance in schemas when you are defining node types, inheriting attributes or something like that?
I think that's still TBD. I'm not sure. I seem to remember Stefan's actually on the call. I think he's actually better placed to actually answer that in particular. Stefan, if you're able to take that question.
I'm happy to, except I didn't hear it acoustically. So if it could be repeated, I'm happy to.
So are there any plans for inheritance in the schema definitions for inheriting attributes or relationships between node types?
I mean, you can set things up so that it effectively boils down to modeling inheritance, but there isn't an inheritance relationship in an object-oriented sense, but you can certainly model hierarchies. If that's
you mean by repeating the relationships in multiple places?
Yeah, I think that's what it boils down to, but the system will understand if you set up a person node to have, you know, certain properties, and then of course in person employee has additional properties that will be understood. So it is possible to create hierarchies.
Yeah, got it.
And I want to just make one addition to the reply you gave, Petra, to the previous question. While we will not be providing graph projection in version 1 of GQL simply due to time constraints, I think we all really had to learn how much work it is to write a standard at the level of the quality of the SQL standard. It is a tremendous undertaking, really. But I guess most people don't know that SQL itself is 4,000 pages. We are at 500, but, they are 30 years ahead of us. So we're catching up. It is still, at least there's a trapdoor. The mechanics that the standard provides allows for queries to return graph, and it may be possible to, at least in version 1, emulate such a feature by providing user-defined procedures in the GQL catalog, and those could be returning graphs. So at least we are putting infrastructure in place that allows us to do proper graph projection in version 2.
Okay, George has another question.
Since we got onto the topic, everyone raised the topic of graph schema. What is the semantics of conformance of a graph to this type of schema with node and edge types?
You may need to go closer to the mic.
Did you guys hear me?
Yes, I'm just thinking about that. Actually, I've not worked on that section myself. Stefan, are you able to?
So is that like?
We've got more details on that. I wonder if we should maybe take that offline. I'll be coming down later on, so maybe.
I'm just wondering how strict it is. Is that mandatory structure, allowed structure, or you have to have exactly that structure and only that structure?
Oh, exactly that structure. No, it's either you have the schema or you don't. And depending on what your graph type is, all instances in your actual data graph need to conform to that graph type.
Okay, that was my question. Thank you.
But you can have a superset, I hope.
No, that's not.
You cannot have a superset, or you can have a superset.
So maybe to phrase it a bit differently, you can either have, or that's where we want to go, the unspecific graph type where you have no schema. If you have schema, you state explicitly everything that is allowed in an instance of the type. But of course, there is a natural subtyping relationship between multiple such schema-based graph types, right? I mean, if a graph type B just allows more things than a graph type A, then it is naturally a super type.
No, but it has to be explicit, right?
It has to be explicit. We are leaving kind of between those extremes, no schema and explicitly declared schema. There's of course partial schema in the middle. We have decided to leave that for version 2.
Okay.
Okay.
It's too much work. Yeah.
Too much work.